Hello students, good morning. I'm your maths teacher and my name is Jagan Karthik and I'm specially teaching for you people from Chennai. Today we are going to learn some new topic, that is polynomials. In class 9 you would have already learned what are polynomials and other things, and class 10 polynomials is not going to be a greater deal for you people. So in class 10 board exam, you'll be having 21 mark questions. This is a new pattern assigned by the CBSE. So you'll be having 21 mark questions. And in order to answer those questions, you need to be thorough with your book. And rather, that is right from your introduction, everything you need to know very well. So we have planned this session very well that you'll be thorough with each and everything in your textbook. And this is a polynomial session, and I'll make sure that you're going to excel in your polynomial questions in your board exam. And please keep your book along with you while watching this session, and without wasting time, let's move on to the session. Okay. So if you open your book and take the polynomials, they would have started with a description of what is the degree of a polynomial. So I'll tell you what is a polynomial. So polynomial is nothing but a mathematical expression that consists of variables, constants, and coefficients of the variables. That's it. So polynomial is nothing but a mathematical algebraic expression. What is an expression? Expression consists of variables, constants, and coefficients. So expressing using these terms is a mathematical algebraic expression. And if you're not familiar with these terms like coefficients or constants or variables, I believe you will be familiar with those terms by the end of the session. Okay. So now I'll tell you what, now I have told you what is a polynomial, and let's move on to what is the degree of a polynomial. So if you see here, okay, you will be having, so here, degree of a polynomial. What is the degree of a polynomial? So degree of a polynomial, wait, I have given a brief description of whatever is required, and please listen to please listen to the audio also, so that you may not miss some important points. So let's move on to the lesson. What is the degree of a polynomial? Degree of a polynomial is nothing but it is the highest power of x in a polynomial. So degree of a polynomial is the highest power of x in a polynomial p of x. We can express, we are expressing the polynomials in the form of p of x. So we are using p of x. And now let's see the degree of a polynomial. The first example. In first example, you're having 8x plus 4. P of x is equal to 8x plus 4. And here 8 is the coefficient of x. You know that. So 8 is the coefficient of x, because, and 4 is the constant of the polynomial. So then what is the degree? And I have written that the degree of the polynomial is 1. So you may ask me, how did I come to know that degree of the polynomial is 1? So by the definition, the highest power of x in a polynomial, p of x. Okay, here we have got that p of x is 8x plus 4. And here we have x, and the power of x is 1. And the highest power in the polynomial, let it be so this is the polynomial which we are, so the polynomial given here is 8x plus 4, and the highest power of x is 1. And so that is only the degree of the polynomial. So since the power of x is 1 over here, it is the degree. So therefore the degree of the polynomial is 1. Okay. And this type of polynomials are called as, and here this type of polynomial is called as a linear polynomial. So since why it's called as a linear polynomial? Because the degree of the polynomial is 1, therefore it's called as a linear polynomial. In the second example, here p of x is going to be equal to x squared minus 2x minus 8. Here 1 is the coefficient of x squared. So and minus 2 is the coefficient of x. Minus 8 is the constant of the polynomial. So I believe you could understand what are these things. And 2 is the degree of the polynomial. Why 2 is the degree of the polynomial? Because the highest power of x. Here there are, so here we have minus 2x as well as 1x square. But here 1x square is having the highest power, that is 2. So therefore, since the degree of a polynomial is the highest power of x in a polynomial p of x, therefore 2 is the degree of the polynomial, and such polynomials are known as quadratic polynomials. Third example, we have x cubed minus 3x square plus 5x minus 2. Here 1 is the coefficient of x cubed. So if you see the coefficient of x cube is 1, and minus 3 is the coefficient of x square, and 5 is the coefficient of x. So, and you know the minus 2 is the constant of the polynomial. Here, since the highest power of x in this polynomial is 3, no, highest power of x. We have many x over here, and the highest power of these x over here is 3. Therefore, 3 is the degree of the polynomial, and such polynomials are known as cubic polynomial. Okay, now we will move on to next what is there in your textbook. That is the general forms of various equations. Like we learn now, we'll see what are the general forms of a linear polynomial, general forms of quadratic polynomial, general forms of cubic polynomial. So that is the next part. It's very necessary to know the general form to move on to the other parts of your. So now we will see the general forms of a polynomial. General form of a linear polynomial is ax plus b, and general form of a quadratic polynomial is ax square plus bx plus c, and general form of a cubic polynomial is ax cube plus bx square plus cx plus d. And you know why the general form of a linear polynomial is ax plus b, because the degree is 1, therefore x to the ax to the power 1 plus b. Similarly, general form of a quadratic polynomial, since the degree of a quadratic polynomial should be 2, that is the highest power of the polynomial should be 2, therefore ax square plus bx plus c is the general form. And the general form of a cubic polynomial, and you know that degree of the cubic polynomial is 3, therefore ax cube plus bx square plus cx plus d is the general form. And very important part of this is, please listen, very important part is a is not equal to 0. A is not equal to 0 in these general forms. Okay, a is not going to be equal to, if a is 0, then what will happen? So let's take example of this quadratic polynomial. If a is going to be equal to 0, then 0x square plus bx plus c, and you know, like here 0x square is going to be equal to 0. Therefore, the general form of the quadratic polynomial will become bx plus c, which is wrong. Therefore, in all these conditions, a is not equal to 0. Okay, and everywhere a b c d should be real numbers. Okay, so now we'll move on to the next part of the lesson. So if you take your textbook, and here if you see here, we have the zeros of the polynomial. So the next part is zeros of the polynomial. Here, if you see the definition, so if the polynomial p of x has a polynomial in x, and if k is any real number, so the value obtained by replacing x by k in p of x, then the value of p of x at x is equal to k is denoted by p of k. So what does this mean? So it means that if you replace in a polynomial, so wait, I'll show you one example. Here, for example, let's take this equation. Okay, here, if you take this polynomial and if you replace the x value, by k, or wait, let's first learn from the textbook itself. So if you take any value, if you replace k instead of x in a polynomial, here the polynomial given as p of x is equal to x square minus 3x minus 4. Okay, so now if you replace k instead of x, and if you solve the equation, and if you get 0, then k is the 0 of p of x. Okay, so k is the 0 of p of x. So for example, here they are given p of x is equal to x square minus 3x minus 4 and x is equal to minus 1. So here we have, so if we substitute minus 1 instead of x, we get p of minus 1 is equal to minus 1 to the whole square minus 3 into x as minus 1 and then minus 4, which is equal to 0. That is equal to 0. And similarly, if you substitute 4, which is equal to 4 square minus 3 into 4 minus 4 is equal to 0. So this is also 4 is also the 0 of the polynomial and minus 1 is also the 0 of the polynomial. So in order to know how many zeros a polynomial consists, okay, so we can find the number of zeros by seeing the polynomial. So if we find whether the given polynomial is a linear polynomial or a quadratic polynomial or a cubic polynomial, we can find how many zeros does it contain. So for example, a linear polynomial will contain only one zero. A linear polynomial will contain only one zero. A quadratic polynomial, for example, see, this is a quadratic polynomial. Why this is a quadratic polynomial? This is a quadratic polynomial because x square, the highest power, the degree of this polynomial is 2. Therefore, this is a quadratic polynomial. And since it's a quadratic polynomial and its degree is 2, it consists of 2 zeros. So if you take a polynomial and if you find the degree, so how the degree is same as the number of zeros of the polynomial. For example, if you take a polynomial that consists, so if you take a polynomial that has a degree of 6 or 7, so if the degree of a polynomial is 6 means it contains 6 zeros. If the degree of a polynomial is 3, it is a cubic polynomial, then it contains 3 zeros. Okay. So now we will move on to the geometric meaning of. So now let's move on to the geometric meaning of the zeros. Okay. So now you have the coordinate system, coordinate graph in front of your system. Here you have those x-axis and y-axis, everything. So now they're given this and they have asked you to find how many zeros does a poly. So now the question is, how many zeros does this polynomial contain? So you need to find it using the graph given. So definitely this graph is going to be a linear polynomial, and since the x intersects in only one place, and therefore it's a linear polynomial, and the number of zeros. So what you can find from the graph, it is like how many zeros does a polynomial contain after the graph given in the question. So you can find how many zeros does a polynomial contain from the graph given in the question. Here, since the parabola, what is a parabola? Parabola is the slanting curves in the graph. For now, you only have parabola, that is the curves in the graph. So for example, this is a parabola, or this is also a parabola. So the curves in the graph are called as parabolas. Okay. So from this parabola, only the parabola intersects in only in one place in the x-axis. And so therefore, the number of zeros of the polynomial is 1. So now the next part is, how many zeros does this polynomial contain? Since the parabola intersects the x-axis, it intersects this x-axis only in 2 places. Since it intersects in 2 places, 1, 2. So it intersects in 2 places. Therefore, the number of zeros of the parabola, that is the parabola is expressed form of the polynomial ax square plus bx plus c, and this parabola is in the form that it intersects the x-axis in 2 places. Therefore, the number of zeros, it is not the zeros, the number of zeros of the polynomial is 2. Now we have this polynomial, so we can express this polynomial in the parabola like this. Okay, or wait, I'll get it to clear. So we can write this, we can draw this polynomial, we can draw the cubic polynomial like this. And since this parabola intersects in 3 places, in the x-axis, you should not see the y-axis, only in the x-axis, it intersects in 3 places, 1, 2, and 3. Since it intersects in 3 places in the x-axis, the polynomial contains 3 number of zeros. It contains 3 number of zeros. So why should we know these things are? In the question, they will give you only the graph. They will give you the graph, and with parabolas intersected, and they will ask you to find how many number of zeros. So for finding the how many number of zeros, you should check at how many places the parabolas intersect the x-axis. So you should see only the x-axis. And so for a cubic polynomial, the parabola intersects at 3 places, 1, 2, 3. So the number of zeros for the polynomial for this parabola is 3. Okay. So now the next example of finding the number of zeros using the graph. So if the question is like this, how many number of zeros? It is going to be equal to 0. Why? Because the parabola does not intersect anywhere in the x-axis. So this is the x-axis, and since the parabola does not intersect anywhere in the x-axis, therefore the number of zeros for the given polynomial is 0. Next. So if the question is like this, so like find the number of zeros for this polynomial or for this parabola. So what are the number of zeros for this parabola? It is 0. Why? Because it intersects nowhere in x-axis. You never mind about the y-axis. while finding the zeros. So it does not meet anywhere in x-axis, right? Therefore, the number of zeros for a polynomial, for the given polynomial or for the given graph is 0. Okay. Now we will move on to the next topic. If you have any doubts, I'll tell you later on how you could ask your doubts. So before that, we can recall each and every topic once. So for a linear polynomial, normally in the question, if the linear polynomial is given, it will be like ax plus b. For that, the line will be a straight line. So the graph will be like a straight line. So it will go like this, and this line will be ax plus b. So this intersects in only one place in the x-axis. Therefore, it consists 1, 0. Okay. So for a quadratic polynomial ax square plus bx plus c, it will be like in the form of parabola. Okay. So here it intersects in two places. Therefore, it contains two zeros. Or even the quadratic polynomial can also be like this. The graph of quadratic polynomial can also be like this. But the zeros, but the zeros is only one, right? So at times it means that we'll be having two zeros. So both the zeros of the quadratic polynomial is same. For example, if this point is minus 3, 0, then both the zeros of the quadratic polynomial is minus 3 and minus 3. Okay. And now for a cubic polynomial, ax cube plus bx square plus cx plus d. So it will be like this, such a way that it intersects in three places in the x-axis, and therefore the number of zeros of such a polynomial, or in you can find it from the graph that the number of zeros are 3. Okay. So now we will move on to the next topic, that is how you can find the zeros and other things. We will see the next session. So now we will work on the exercise questions. Now take exercise 2.1. Exercise 2.1. So if you see the first question, so the exercise contains only one question. And before you watching it further, I will give you 1 minute. So within this 1 minute, solve all these six subdivisions, and then you continue. You pause this session and you solve all these 6 subdivisions, and then you continue with the session. Okay. Now the solutions to these questions. In the first question, the first subdivision is like, so now the first subdivision of the only question of exercise 2.1 is like this. So the number of zeros, they have asked you to find the number of zeros from the given graph. So what is the number of zeros in this question? The number of zeros in this question is 0. Why? The answer is 0. Why the answer is 0? Because the line, or in the question, the line does not intersect anywhere in the x-axis. In this x-axis, this line does not intersect anywhere in the x-axis. Therefore, the answer is 0. Now, the second subdivision, it is like, so there is a O in between. So what is this 0 in between? They are given. It is the origin of this coordinate. Of these coordinates, it is the origin. So which you have learned already in coordinate geometry class 9. So here, the second subdivision is like this. So what is the answer for this subdivision? Answer is 1. Why the answer is 1? Because The parabola. What is a parabola? Parabola are these curves, right? So it is also similar. This is also a parabola. Wait, I'll make it more clear. Wait. Okay. This is also a parabola. So parabola nothing but curves in the graph. Okay. So here, since the parabola intersects in only in one place in the x coordinate, so it intersects in only in one place in the x coordinate. Therefore, the number of zeros for the given graph from the given graph is 1. Therefore, the answer is 1. Now, the third subdivision is like this. Okay, kind of like this. So here, since this parabola intersects in 3 places, the number of zeros is 3. Therefore, the answer is 3. Okay. Why answer is 3? Because the parabola intersects in 3 places. Therefore, the number of zeros is 3. And from the question, what is required? You need to find the number of zeros. Therefore, the answer is 3. Okay. Now, in the fourth subdivision, it's like this. Since, okay, wait. So, what is the answer? Answer is 2. Why the answer is 2? Because this parabola intersects in 2 places in the x-axis. Therefore, the number of zeros is 2. So now, if you take a parabola like this in the y-axis, the number of zeros is 0 because it does not intersect anywhere in the x-axis. So in such parabolas which intersect 2 places in y-axis does not matter. So please never ever see the y-axis while finding the number of zeros from the given question. Only see the x-axis. Here in the fourth subdivision, since this parabola intersects in 2 places in the x-axis, it intersects in 2 places in the x-axis. Therefore, the number of zeros are 2. Okay. Now the fourth subdivision goes like this. Okay. So now what is the answer? Answer is, and the answer is 4. Why the answer is 4? Because the number of zeros are 4. And since the parabolas intersect the x-axis in 4 places, 1, 2, 3, 4. Since it intersects in 4 places, the number of zeros are 4 and the answer is 4. Now we will see the the sixth subdivision. Now here the answer is, so tell me what is the answer? So the answer is, you can find 1, 2, 3. Therefore the answer is 3. Since the parabola intersects in 3 places in the x-axis, 1, 2, and 3, the answer is 3. So therefore the number of zeros, therefore the number of zeros are 3 and the answer is 3. Now we will proceed further on the next part, that is the relationship between zeros and the coefficient of a polynomial. So we'll move further. Now we will see the relationship between zeros and coefficients of a polynomial. So now you have already learned on how to solve a quadratic equation. So for example, let's take a quadratic equation. P of x is, so first let's take a quadratic polynomial. 2x square minus 8x plus 6. So from the sum and product, you can know that you can solve it like 2x square minus 6x minus 2x plus 6. Right? So this you can again solve it like, you can take common. 2x is the common x. Okay, x minus 3 and minus 2 and it's again x minus 3. Now, know these steps already, which you had learned in class 9, 2x minus 2, and this can be written as x minus 3. From this, you will know that the zeros are, so at last we got that 2x minus 2 into x minus 3. From this, you can know that the zeros are further that x minus 1 into minus 3. And when x minus, so for finding the zero of this polynomial, can solve it like you should equate it to 0 and x minus 1 is equal to 0 and x minus 3 is going to be equal to 0, x is equal to 1 and x is equal to 3. Therefore, the zeros of this polynomial is 1 and 3. Okay, 3. So these are the zeros. So now we have found the zeros of this polynomial. So the zeros of p of x is 1 and 3. So now let's find the sum of these zeros. So let's take 1 to be alpha and 3 to be beta. So what are these symbols? So if you write this, this is known as alpha. And if you write like this, it's known as beta. Okay, these terms are required to know. Okay, for further steps in your mathematics for class 10 and polynomials, you need to know these things. And this is known as gamma. This is known as gamma. Okay. Wait, I'll make it more clear. I guess it's not neat. This is known as gamma. So gamma, we can further in lessons, you will know why we use gamma and all. For now, we will use alpha and beta. Okay, so let's take 1 to be alpha and 3 to be beta. So these are the zeros of the polynomial. We represent these things for zeros of the polynomial. Okay, we represent all these things like alpha, beta, and gamma for zeros of the. So we represent all these three things for zeros of the polynomial. We use gamma because in cubic polynomial, you will be having 3 zeros. And so in such situation, you require another variable also. Therefore, we use another constant. So for that, we use gamma. Okay, for now, we have only quadratic polynomial. So after solving this quadratic polynomial, we have got the zeros and we are representing them as alpha and beta. So an alpha plus beta. So let's find the sum of the zeros. So let's find sum of the zeros. That is alpha plus beta is equal to what? So 1 plus 3 is 4. And let's find the product of these two zeros, alpha into beta. So what is alpha into beta? 3 into 1, 3 into 1, that is equal to 3. Okay. So now we have got sum of the zeros, that is 1 plus 3 as x plus alpha plus beta, which is equal to 1 plus 3, which is equal to 4, and alpha beta, which is equal to 3 into 1, which is equal to 3. So if you observe this, okay, if you observe sum of zeros, alpha plus beta will be equal to minus b by a of the quadratic polynomial. Okay, wait, let me clear the board. So when you observe these things closely, you can find that sum of those two zeros, alpha, sum of these two zeros, alpha and sum of beta will be equal to minus b by a of this quadratic polynomial. So you can be like, what is a and what is b in this quadratic polynomial? So we can see. So that's why, this is the reason why I gave the general form of the polynomial. So if you see the general form, so always we represent a quadratic polynomial in its general form, right? So the general form is ax square plus bx plus c. So the general form is ax square plus bx plus c. And you see, when you compare these two, like 2x square minus 8x plus 6, and if you compare with ax square plus bx plus c, you get that a is equal to 2 and b is equal to minus 8. Since it's plus, and the general form is ax square plus bx, but the p of x, the given equation over here is 2x square minus 8x. It's minus. Okay. Therefore, you should write b is equal to minus 8, and you got that c is equal to 6. Okay, so it's when you compare it with the general formula, you get that a is equal to 2 and b is equal to 8 and c is equal to 6. So when you do like, so when you put alpha plus beta, when you need to find the sum of the zeros. So alpha plus beta, I have given that it is going to be equal to minus b by a. So let's verify it. So alpha plus beta, I given it as minus b by a, which is equal to, so what is minus b by a? Minus of minus 8. Minus of minus 8 by, what is a? 2. So it's going to be equal to 8 by 2, which is equal to 8 by 2, which is equal to 4. So, and we can verify this. So we have got alpha plus beta is equal to 4. That is, if we substitute minus b by a, and we have got 4. Similarly, see, after adding both, we have got 4. Okay. So you can use it simply, like when you question, they'll ask you to find find the sum of the zeros or product of the zeros. So simply you can substitute minus b by a and you can do it. In this session, we will do all the basic things. From next session onwards, you'll find some higher problems, which will be easy. But this is the introductory class. Oh, yeah. So you keep it. So you better understand everything properly. And if you have any doubts, I will tell you later on what to do it and how to go on with it. Wait, at the end of the session, I will tell you. So now let's verify product of zeros. That is alpha, beta. I have given it as c by a. Right. So you know that alpha into beta. What is alpha and beta in the sum? Alpha and beta is 1 and beta is 3. So alpha beta is going to be equal to c by a. That is, so let's verify this. Okay, let's verify. So I'm and alpha into beta. Alpha into beta. Wait. Alpha into beta. Alpha into beta is c by a I have given. So what is c over here? 6. And what is a? 2. So what is 6 divided by 2? 3. And already we have found the zeros. And if you multiply both the zeros, okay? Wait, I'll tell you. And now you can see that alpha into beta is 3. Alpha into beta is 3. Yeah, we are back. Wait, there is a technical issue. Yeah, now it's fine. We are back. Here, we have found that alpha into beta, which is equal to c by a. We have this equation. It's equal to c by a. It's equal to 3. And we have already found the zeros of the polynomial. It is 1 and 3. So when you multiply these two zeros, you get answer as 3. So which is verified. Therefore, you need to know these things. Okay. Alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. And these things, listen very carefully, these things are only for quadratic polynomials. Now next we will see for cubic polynomials. Okay. Before that, we will learn one more thing. So in the question, if alpha plus beta is given and alpha beta is also given. Okay. Alpha plus beta is given and alpha into beta is also given. Then they might ask you to find the polynomial. They have given you alpha and beta, and they have given you alpha into beta, and they ask you to find the polynomial. How can you find the polynomial? So there is a general form. So to find the polynomial, what can you do is, wait, you can substitute x square minus alpha plus beta into x plus alpha beta. Okay. So when alpha and beta is given, alpha plus beta is given, and alpha, now they are in the question. So this in the question they have given you alpha plus beta and alpha beta. So they are asking you to find the polynomial. They are asking to find the polynomial. Since only alpha plus beta and alpha beta are given, alpha plus beta is given and alpha beta is also given. Therefore, it's a quadratic polynomial, and it's because these are, and therefore this is the general formula. From this general formula, you substitute alpha plus beta and alpha beta. You substitute these two things and let rest of the things be same, and you get the answer. So at times it is also necessary to put k as constant. K into x square minus alpha plus beta. It is necessary to put the constant k because when you solve a question, when you solve a quadratic equation, you will equate it to 0. And if you have anything in common, we will take the commons out. So such a common is k, that is a constant. And when you put and when you substitute it over there, it will get cancelled. 0 by k will get cancelled, and you will get x square. 0 by k is 0, so it's going to be same, and sorry, 0 by k is 0, it's going to be same, and you will get the above equation. You will get the above equation, x square minus alpha plus beta plus alpha beta. Therefore, it is also necessary, where I'll show you clearly, it is necessary. So when the question is alpha plus beta is given and alpha beta is given. So normally it's necessary to put a k, and then you start with x square minus alpha plus beta into x plus alpha beta. Okay. Okay. Now we will move on to cubic polynomials. On how will you find the sum and other things on for cubic polynomial, you can see. So now let's see the example of a cubic polynomial. That is the relationship of the zeros between the coefficients, relationship between the zeros and coefficients. Now if you take a cubic polynomial, here the cubic polynomial is given, that is 2x square. Okay. So this is the cubic polynomial, 2x square minus 5x, 2x cube, sorry, 2x cube minus 5x square minus 14x plus 8. Okay. From this, they have given, and the zeros for this cubic polynomial are 4, minus 2 and half. If you want, you substitute 4 instead of x and find, you'll get it as 0. When you solve this equation, substitute minus 2 instead of x, you will get it as 0. Substitute half instead of x. You will get it as 0. So if any two zeros are given, you can find all the zeros of this cubic polynomial. If any two zeros are given, you can find all the zeros of this cubic polynomial. So we can learn it later. For now, we take the zeros to be 4 minus 4 minus 2 and 1 by 2. Okay, the zeros of this polynomial. It consists of only 3 zeros. Why only 3 zeros? Because the degree is 3. Since the degree is 3, it consists of only 3 zeros. So you will take this 0 to be alpha, this 0 to be beta, this 0 to be gamma. That is what I have already told you. This is known as alpha, this is known as beta, this is known as gamma. So we will assign each and every zero with a constant like alpha, beta, gamma. We have assigned this, right? So now I have written the general formula of a cubic polynomial. This is the general formula. What is the general formula? Ax cube plus bx square plus cx plus d. This I had already given general forms of various polynomials like the linear polynomial, quadratic polynomial, and cubic polynomial. So here the general formula of a cubic polynomial is ax cube plus bx square plus cx plus d. So when you compare these two, you get that a is equal to, a is equal to 2. Wait, I'll write it neatly. Or I'll rub this way. You just see this. You just see to that a is equal to 2. B is equal to minus 5. Why B is minus 5? In general form, it is plus B. But in the question, it is minus 5. Therefore, B is equal to minus 5. And C is equal to minus 14. Similarly, in general form, it's plus C. And in question, it's minus 14. Therefore, C is minus 14. D. What is D? D is equal to 8. Okay, just you see to this and we'll move further. Okay, once again I'll tell you from comparing the general formula. Okay, I'm comparing this general formula with this question given. You got that A is equal to 2, B is equal to minus 5, and C is equal to minus 14, and D is equal to 8. And we have already given that the zeros. We have already given that the zeros are 4, minus 2, and half. 1 by 2, that is 1 by 2. And we have assigned constant for each and every zero. Alpha, this is beta, and this is gamma. Okay. Now we will see what is alpha plus beta plus gamma. So that is the relationship. Okay. And similarly, we have already seen the relationship for quadratic polynomials. There are a few other relationships. Similarly, there are a few other relationships that we can see now in the cubic polynomial on how to go at it. So now I'll rub the board and I'll show you the relationships. So now here I have given the relationship between the zeros and the coefficients. So here we have alpha, beta, and gamma. What is alpha, beta, and gamma? These are the zeros. So when you substitute these zeros in the quadratic polynomial written in the last page, when you substitute these values, you will get 0. When you solve it, you will get 0. So therefore, these are the zeros, and only there are 3 zeros for any cubic polynomial. Why? Because the degree of the cubic polynomial is 3, and we had already learned that the degree of a polynomial is same as the number of zeros of the polynomial. Okay, therefore alpha plus beta plus gamma is equal to minus b by a. So there are few new relationships. Okay, we will understand, we can verify it and we can prove it. Okay, you can understand this. Alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c by a. alpha, beta, gamma is equal to minus d by a. So what are these A, B, C, D? We from already from the general form. We have compared the given question with the general form, and we have got A is equal to 2, B is equal to 5, and C is equal to minus 14, and D is equal to 8. Therefore, now we can verify the relationship. Now, first relationship, alpha plus beta plus gamma is equal to minus B by A. So we can verify it. So alpha plus beta. So when you add all these, alpha, beta, gamma, what will you get? So, so when you add all these, you get that 4, 4 plus of minus 2 plus half. So when you do 4 plus of minus 2 plus half, what do you get? 4 minus 2 plus half. That is equal to 2 plus half. Right? That is equal to 4 plus 4 by 2 plus 1 by 2. Taking LCM, that is equal to 5 by 2. Okay, this is the thing, that is alpha plus beta plus gamma, that is sum of all these alpha, sum of all these alpha, beta and gamma, you got it as minus 5 by 2. Okay, so I'll take it down. Wait. So we have got that alpha plus beta plus gamma is equal to 5 by 2. Now we can verify whether it is equal to minus b by a. So we have b here and we have a over here. Okay, so let's take b. Oh, sorry, b is minus 5, right? From when we compared it with the, when we had compared, we had got b is equal to minus 5. So A is equal to 2, B is equal to minus 5, C is equal to minus 14, and D is equal to 8. Yeah, I'm sorry. Now we can compare it with alpha, beta, and gamma. So according to the general formula, according to the relationship, these are the relationships. So from this we have got that it said that minus b by a. So what is minus b by a? Minus, right? First you should write minus, and what is b? B of minus 5 by what is a? 2. So which is, so what is minus of minus? It is plus. So 5 by 2. Hence verified. Right. So we have proved that alpha plus beta plus gamma is equal to minus b by a. Now let's verify the product of 0 taken 2 at a time. So the product, so these are the product of the 0. It is said that, so it is the product of the 0 taken 2 at a time. Two zeros are taken and product is done and it's multiplied. So product of these two zeros taken 2 at a time. Okay. So now we can multiply it. What is alpha into beta? 4 into minus 2 is minus 8 plus beta into alpha. Minus 2 into 1 by. So it is minus 1, and we have gamma into alpha. Gamma into alpha is plus 2. What is gamma? Gamma is half. Half into 4 is 2. So therefore it's plus 2. What do you get? Minus 8 minus 1 minus 9 plus 2. What do you get? Minus 7. It is equal to minus 7. Minus 9 plus 2 is minus 7. So, and this relationship is given as C by A. This relationship is C by A. So let's verify it. So we have C is equal to minus 14 over here. C, so I'm substituting it. So I'm taking C, it is only C by A. It's not minus C by A. It's only C by A. So I'm taking minus 14 just like that. and a is 2. Now you divide these two, you get minus 7. So now we have already got it's minus 7, and dividing also and verifying it with relationship also we have got it as minus 7. So hence verified. Okay. So therefore alpha beta plus beta gamma alpha is equal to C by A. Now let's verify for the product of the zeros, that is alpha, beta and gamma. It is given as minus D by A. So what is alpha into beta into gamma? 4 into minus 2 into half, right? So that is equal to minus 4. So I have given that the relationship for alpha into beta into gamma is minus D by A. So what is my now I'm substituting it. I'm substituting the relationship. We already have D is equal to 8 and A is 2, right? So, but here it's given as minus D by A. Alpha into beta into gamma is minus D by A. So alpha, what is alpha into beta into gamma? We have found it as minus 4. Now I'm substituting minus D by A. Minus D is minus 8. Minus 8 by A. What is A? A is 2. Minus, okay, minus, that is nothing but minus of plus 8. Right? Minus of plus 8. So because general formula, you should substitute as minus. So which we had already seen it for alpha plus beta plus gamma. Now it is minus into plus 8 by 2, which is equal to minus 4. So alpha into beta into gamma is minus 4. Okay. Therefore, we have verified this also. So therefore, alpha into beta into gamma is minus D by A. So take these things as notes. That is alpha plus beta plus gamma is equal to minus D by A. Take it as notes. Okay. These are for cubic polynomials. These are for cubic polynomials. My handwriting may not be clear, but please listen to the audio. Okay. So now we will go on a brief summary for a quadratic polynomial. Okay. This is for a quadratic polynomial. This is the ax squared. Wait, I will get on this spotlight. Ax squared plus bx plus c is the general formula. This is the general form. Not formula, sorry, form. This is the general form. And alpha plus beta is equal to minus b by a, and alpha into beta is c by a. So this is b, and you need to substitute minus with it. So which you had already seen such examples. So you get thorough with it. Alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Now next for a cubic polynomial. For a cubic, so it's for a cubic polynomial, the general form. So for a cubic polynomial, this is the general form. Ax cube plus bx square plus cx plus d is the general form. And for this alpha plus beta plus gamma. What is alpha and beta? Alpha and beta are the zeros of the quadratic polynomial in this situation. For a quadratic polynomial, alpha and beta are the zeros for this thing, right? Only there are two zeros for a quadratic polynomial. Why? Because the degree is 2. The maximum degree for a quadratic polynomial, the highest degree for the quadratic polynomial is 2. Therefore, only there are two zeros for a quadratic polynomial, and the sum of both the zeros is minus b by a. And the product of both the zeros is c by a. Similarly, for ax cube plus bx square plus cx plus d, we have alpha, beta, and gamma. This is for a cubic polynomial. Alpha plus beta plus gamma is equal to minus b by a. Alpha, beta plus beta gamma plus gamma alpha is equal to c by a. Alpha, beta, gamma is equal to minus e by a. What are alpha, beta, and gamma? Alpha and beta and gamma are the zeros of those cubic polynomial. So the zeros of those cubic polynomials are alpha, beta, and gamma. And the cubic polynomial consists of only 3 zeros. Why? Because the degree of a cubic polynomial is 3. That is the highest power of x in a polynomial, p of x. So I believe that you people are thorough till whatever is taught till now. Okay. If any doubts, wait. Now we are ready to face the questions given in the textbook. So let's take example 2 in page number. Let's take example 2 in page number 30. Take page number 30. In that, it's example 2. Page 30. In that, example question 2. Okay. In that, you see in example 2. In example 2, the question is find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. So there is a method for doing such sums. That is method in the sense verification must be done properly. You know how to find the zeros for this quadratic polynomial. That is for x square plus 7x plus 5, right? Sorry, it's 10. It is 10. So the given question is some x square plus 7x plus 10. So now how do you solve it? We have got for 10 as 5 and 2. So you substitute this x square plus 5x plus 2x plus 10. So now we have separated 5x plus 2x. So now you have got that. I'll take x common, x plus 5 plus 2 common, x plus 5. So at end, you get that x plus 2 is equal to 0. X plus 5 is equal to 0. Sorry, my handwriting may not be proper, but try to understand. Okay. And then we will get that x, we will get it as x plus 2 into x plus 5. So therefore, we need to find the 0. We will equate it to 0. And therefore, x plus 2 is equal to 0 and x plus 5 is equal to 0. And what are the zeros now? Now you got the zeros. Now the zeros are, what are the zeros? Minus 2 and minus 5. So the zeros are minus 2 and minus 5. So I'll take this to be alpha and take this to be beta. Okay. And now we are going to verify the relationship. How will you verify the relationship? So from the given question, when you compare it to the whatever, what had I said? I had said that the question is given like 7x square plus 7x plus 10. And the general formula is ax square plus bx plus c. Now compare with these both. Compare this and get that. Then you will get that a is equal to 1, b is equal to 7, c is equal to 10. Right? Now p is equal to 10. Now you can find alpha plus beta. That is only we are verifying the relationship. Alpha plus beta. What is alpha plus beta? Now you should not use for verification. Now you add these both minus 2 and minus 5. So it is minus 7. And now you substitute, we show that this is also equal to minus b by a. How will you show that? By substituting minus we had already had 7 minus b by 1. A is equal to 1. So this and this are verified. Hence proved. Okay. So now I'll show you the solution on how to write it. Okay, for now, briefly I will teach you on how to go with it. I'll show you the proper solution. I will show it to you. Now the next case. Now we have the next case. Okay, wait. Oh, sorry. So next case is alpha into beta. This is how you should verify. Next, you should verify it for alpha into beta, whether it is coming correct. So this is equal to C by A, right? But you know how to multiply. Minus 5 into minus 2 is 10. So I must get 10 if I do C by A. If I do C by A, I should get it as 10. Right? So what is C by A? C is 10 and what is A 1? So this is equal to 10. Therefore, these two are verified. Okay? Hence, you should write at last, you should write it at hence verified. Okay? Take these as notes. So this is how you must write the solution. You can see your textbook. X square plus 7x plus 10. As I expressed, at last you have got the zeros as minus 2 and minus 5, right? You have got the zeros as minus 2 and minus 5. And you know sum of zeros is minus 7. Right? Because how do you find the sum of zeros? By adding these both minus 2 and minus 5, which you have got minus 7. And when you take our relationship, that is how you should verify. Then you must take our relationship, that is minus b by a. That is what they have given in the textbook. They have given it as minus of coefficient of x. What is minus of coefficient of x? What is coefficient of x? Nothing but b. So now they are given minus of b and coefficient of x square. So in general formula, you might be confused while seeing your textbook. What is this minus coefficient of x? So if you take the general formula, ax square plus bx plus c, right? Here, what is the coefficient of x? Coefficient of x is b. And what is the coefficient of x square? This is x square. Coefficient of x square is a. Okay. So nothing but, therefore I'm substituting, right? So what is the coefficient of x? We have got it as b. This is equal to minus b by a. Okay. This is equal to minus b by a. So you should verify it like this. Your sum of zeros is equal to minus b by a and product of zeros. What are the product of zeros? You know that you can multiply minus 5 into minus 2, which you get 10. And the constant term is c. So this is only the constant term. Okay. Therefore, this is equal to c. And as already said, coefficient of x square. Coefficient of x square is a. C by a. So this is how you verify. So you check the example 2 in your textbook. If you don't understand, even though you don't understand, wait, you can ask me doubts through one thing. I'll tell you. Example 3 is going to be your homework. You should solve it and then you should post the answer. I'll tell you one mean through that. You should post the answer. I'll tell you the basic things. Please don't see the book and do it. Okay. So the next question is given, the p of x is given as x square minus 3. You can write 3 is as root 3 into root 3, right? So 3 is nothing but root 3 into root 3. Therefore, you can also write, so root 3 is into root 3 is nothing but root 3 the whole square. So this question, you can solve it like this. You take x square, okay, x square minus root 3 the whole square. And you solve. Okay, you know a square minus b square formula. Then you solve it and you can see, you can be like x square minus 3 is a quadratic polynomial. Why? Because its highest power is 2. So this is nothing but x square plus 0x minus 3. That's it. So this is the form. You can be like, sir, b is not here. So b is nothing but 0. And from this you can get it. So I want you to solve it, and then you substitute, and then you post the answer in the group, or you can verify it with the example given below. First you yourself solve it, and then you verify it with the answer given in the textbook. Then we'll go on to, then you will move on to example 4. See, one such question is here, example 4. I had already said they would have given you the sum of the zeros, that is alpha plus beta, and they would have given you the product of zeros, alpha into beta. They would have given you the alpha into beta and alpha plus beta. Okay. So they are given alpha plus beta is minus 3. Alpha into beta is, what is alpha into beta? 2. They are given. This is the question. Now they are asking you to find the quadratic polynomial. How will you find? So the quadratic polynomial, how will you find? So let's take the regular formula, x square minus alpha into beta into x plus alpha beta. So which I had already said much before. Okay. That is x square minus alpha plus beta plus alpha into x plus alpha beta. So you just substitute it. X square mod is alpha into beta minus 3. So minus of minus 3 into x plus alpha beta. What is alpha beta? 2. Now again solve, because minus of minus is there. X square minus minus of minus is plus, so plus 3x and plus 2. This is p of x, and this is the required, this is the required answer. Okay. Now we will move on to example 5. Okay. Example 5, you can do it by yourself. It is very simple. It is nothing but, which I had already said you. I had explained it to you in the form of alpha, beta, gamma. And then again, I had said to you on how to verify it. So you can see it, and I'll tell you the method. Okay. They are given you the zeros, and the polynomial is given. Alpha, beta, gamma is given, and the polynomial is also given, right? So you substitute alpha with p of x, beta with p of x, gamma with p of x. So you substitute, you would have got, so I'll write the p of x, right? 3x cube minus 5x square minus 11x minus 3. So you substitute alpha instead of, wait, I'll show you, I'll spot it for you. So you substitute alpha instead of x, all the x's over here, and you find, and you can verify if it is, if that is equal to 0, then yes. So they were asking you to verify whether alpha, beta, and gamma are 0. So if you substitute alpha instead of x, and if you get the answer, if you solve it and if you get it as 0, then alpha is the 0 of p of x, that is 3x cube minus 5x square minus 11x minus 3. Similarly, you substitute beta instead of x. So, and again, if you solve it, if you get it as 0, then this is also 0. And gamma, similarly, substitute gamma instead of x. And if you solve it and if you get 0, then that is the 0 of p of x. That is this expression. This is p of x is nothing but the polynomial. Polynomial is the expression. So in this expression, if you get all these as 0, then it is, then these three are the zeros. So you can verify. So basically, you should verify it like that. When they have asked, verify that 3 comma minus 1 comma minus 1 by 3, you substitute in, and first you verify it like this. Then next step, and then they are given in the question, and then verify the relationship between the zeros and the coefficients. I had given to you in the summary, in the summary page, I had given to you all the formulas. Alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma is equal to minus d by a. So you substitute, you know, alpha, beta, gamma. Alpha, beta, and gamma is given. Alpha is equal to 3. Beta is equal to minus 1. And gamma is equal to minus 1 by 3. Substitute all these three things so accordingly in the question. And you know to find, right? Alpha plus beta plus gamma first. Like in the last question in example 2, we did know. Similarly, you do with this and you can do it. And you post the answer at last. Okay. Now we had solved the questions and exercise 2.2. Now you'll take exercise 2.2. Exercise 2.2, this is a homework for you people. Okay, that is you on like you did the example 2, right? Similarly, the first question. In that fifth question, how will you proceed? In the fifth subdivision, how will you proceed? Take t square minus 15. Okay, this is nothing but t square minus root of 15 the whole square. So this is in the form a square minus b square, right? So like similarly, you can do it. So now you got the idea. Write this as t plus root 15 into t minus root 15. Okay. So please try to understand, my handwriting may not be proper. T plus root 15 and t minus root 15 are the, so we have expressed it like this. So from this, what are the zeros? Minus root 15 and plus root 15. So now we verify it with the coefficients. So which I had already done and I had showed you one question. Similarly, you do it. Okay. So I think this is the only question that is kind of tough. So the basic idea is this. You got the zeros as minus root 15 and plus root 15. Okay. Now you can proceed. The second question of exercise 2.2. Second question of exercise 2.2. They are given the sum and product of the zeros. So that also we had done. So, okay, that is similarly to the question number example 4. Example 4 I had showed you. If you want, I'll show the third question, third subdivision. I'll show it again one more time. Okay, alpha. So the zeros are given as 0 and not 0. Sum of zeros are given as 0 and product of the 0 is given as root 5. So this is alpha plus beta and this is alpha beta. You can substitute in this general form, x square minus alpha plus beta into x plus alpha beta. So now we substitute x square minus 0 into x plus root 5. Now we get that x square. So 0 into something is 0. So plus root 5. So this is the answer required. This is the polynomial which is equal to p of x. Okay. So once I will show it to you with the book. So you had seen the example 4 here. So similarly, you should do the question number. All the exercises in 2.2, all the questions in exercise 2.2, you should do it similarly. Okay, for finding, you can find the you can find the polynomial from the thing. So that is sum of zeros are given and product of zeros are given. So from the sum of zeros and the product of the zeros, you can find the polynomial. Okay. So on one question and second question, third subdivision, I had shown it to you. Similarly, you do the other questions and post it down, or you can check the answer in the last. If you had done it as a homework and if you had verified it, you can post it. If you want it to be checked by me, you can post it in the group. Okay, next. I will teach you what is division algorithm, and then we can see the rest of the things in the next session. Okay, we can see what is division algorithm. So now we can see what is division algorithm. If you take, this is the division, right? This is how you divide. So if you take a dividend and a divisor, so this is the divisor and this is the dividend. P of x is the dividend. Okay, I'll spot it to you. So the P of x, this is P of x, that is the dividend, and this is the divisor. If you divide these both, you get the quotient, right? Division. When you normally divide, you get the quotient. And if there is a remainder, you get remainder. So here, in this forms, we get P of x. We can take the dividend as P of x, divisor as G of x, and quotient as Q of x, and remainder as R of x. So this is nothing but remainder is R of x. Okay, I believe you had understood this. So quotient is none. So normally divide, right? So wherever you get the quotient, so the quotient that you get is taken as Q of x. The divisor is G of x, and the dividend is P of x, and the remainder is R of x. So this is very simple. Now, so this is only division algorithm. P of x is equal to G of x into Q of x plus R of x. So now we have got the dividend P of x. So try to understand whatever I'm telling. So this is P of x. Now we are asked to divide. So now what you're going to do is you're going to divide P of x by G of x. Okay. So now while doing so, what is division? You will get quotient, right? So while doing so, you will get a quotient Q of x. Okay. And while doing so, and when you're at the division process, at last you get R of x. If there is a remainder, at last, when nothing more is, when we can divide it no more, we'll get R of x. That is the remainder, right? No need of think. Okay. So that is the remainder. I'm sorry, something happened. So that is the remainder. So R of x is the remainder. So when you take the division algorithm, P of x, okay. So this is P of x, right? Wait, I'll convert. So this is P of x. So when you find, if you want to find P of x, then you multiply G of x with Q of x, and if you add these both, if you multiply G of x into Q of x, what do you get? So you get some value, and when you add it with R of x, if you do G of x into Q of x, and then if you add R of x, you will get P of x. That is what the format is. So, okay. So this is known as division algorithm. Try to understand till what I have said. We are going to end the session now. We had almost tried to cover all. We are halfway done in polynomials. We have a lot to go with. So we have the optional exercises and the exercise 2.3, and then I will give you new worksheets. So try to understand this. I'll give you new worksheets. every time. Okay, and if you have any doubt, that's what I'm going to tell you now. If you have any doubt after seeing this session, if you have some doubt, or if you want to or if you want me to explain something once more, feel free. And very soon a WhatsApp group will be created in your parents' mobile, and in that group even I will be there. A very group will be there, and even I will be there in that group. And you can post the group whatever doubt you have. You can post it in that group, and you can get it clarified by me. Or if you are not feeling comfortable to post the doubt in that group, you can post it. Like I'll be having one more live session in this class. Okay, and we will tell it to you later. I will tell it to you later on how to go with the live session. There is a live session that we both can interact at the same time. Me and the students can interact at the same time. And if you have any doubt, you can feel free to ask to me even at that time. I will tell it to you when we will have a live session. One day we will have live session for at least 2 to 3 hours. And then try to understand till division algorithm, and try if you have other books like R.D. Sharma or something R.D. Sharma and all, you try with that, or or first you complete the homework. Exercise 2.2, you solve each and everything, and then you can try other books. And till division algorithm, you try to understand till what is this division algorithm? Like how did I get this formula? You try to understand this. So that's what I said. P of x is equal to G of x. If you multiply these two and add R of x, you will get P of x. So you try to understand this thing, and we can meet up in the next session. So you're done for the day. Thank you.